This example, we are going to use the Taylor series in the table provided to find the first four non-zero terms of the Taylor series for the function center at x equals 0. In part A, we have the function natural log of 1 plus 2x, which is the similar pattern to the natural log of x plus 1 as x minus x squared over 2 plus x to the third over 3 and so forth as the power series form summation negative 1 to the k plus 1 times x to the power k divided by k and the interval of convergence negative 1 less than x less than or equal to positive 1. To adjust it to fit that term, we can rewrite it as um, this is the natural log of the 2x plus 1 and consider the quantity 2x as one term. So for the natural log of the quantity x plus 1, the quantity x minus the quantity squared over 2 plus the quantity to the third over 3 and so forth. So in the expanded form or the first four non-zero term, that would be the quantity 2x minus the quantity 2x to the second power over 2 plus the quantity 2x to the third power over 3. And the next term, as we see the pattern, that would be negative of the quantity 2x to the fourth over 4 factorial and then plus more terms. So we obtain the first four non-zero terms. To simplify more, we get 2x minus 4x squared over 2 plus 8x to the third over 3 minus 16 x to the fourth over, uh, this is 4, sorry, not 4 factorial. So divided by 4 and then plus and so forth. As we can simplify more to get the natural log of 1 plus 2x in the expansion of the first four terms to get 2x minus 2 times x squared plus 8 over 3 times x to the third minus 4 times x to the fourth plus more terms. And in the summation form, that would be the summation of negative 1 to the power k plus 1 multiplied by the quantity 2x to the power k divided by k from 1 to infinity. For this example, the function x multiplied by the inverse tangent of the x squared. We see the Taylor series center at 0 on the table of the inverse tangent x equals x minus x to the third over 3 plus x to the fifth over 5 and so forth. See this is as an alternating series and the power of our x as the odd power, or the general form in the power series as negative 1 to the power k times x to the 2k plus 1 divided by 2k plus 1 for the absolute value of the x less than or equal to 1. Function f of x as x multiplied by the inverse tangent of the quantity x squared. We can work on using the Taylor series on the table to represent the inverse tangent for x squared. So the quantity x, we're going to replace with the x squared. And at the same time, the whole series will be multiplied by the x factor in the front. So x multiplied by the series as the first term, replace x with the x squared. We get the quantity x squared minus the quantity x squared to the power 3 over 3 plus the quantity x squared to the fifth over 5. And the fourth term would be x squared to the next odd number would be 7 divided by 7 and then more terms. Next, simplify it to be x multiplied by x squared minus x to the second to the third, that is x to the sixth divided by 3 plus x to the 10 divided by 5 minus x to the 14 divided by 7 plus more terms. And then for the multiplying by x all terms to get x to the third minus x to the 7 over 3 plus x to the 11th over 5 minus x to the 15 over 7 and more terms. Or as the power series form, If we use the one before we multiply all by x, going to be x multiplied by the summation of negative 1 to the power k, x now replaced by the x to the second, and then all to the power 2k minus 2k plus 1, sorry, divided by the quantity 2k plus 1, and the power x, power the x as x to the 4k plus 2. Multiply all by x, or all terms in the series by x to get in the summation form as summation negative 1 to the power k, x to the power 4k plus 3, all divided by the quantity 2k plus 1, k starting from 0 to infinity.